All right, so our next equation is the reaction between calcium chloride and sodium phosphate to yield or to make calcium phosphate and sodium chloride. And so this equation's a little bit more daunting, okay, in looks than the other problems that we've looked at, but I think we can handle it. So let's go ahead and get started, right? So again, at first, as always, we make our RAP table. And so we write down which elements, which atoms we're working with in that central column, in that middle column. So we are working with calcium, Ca, chlorine, Cl, sodium, Na, and then PO4, phosphate. Okay, so notice that phosphate is a polyatomic ion. Okay, we're going to treat it like a single element atom in this equation, or when balancing this equation, because phosphate appears on both sides of the equation, right? Whenever we see a polyatomic ion that appears on both sides of the equation, right, in the reactants and in the products, we can treat it like a single element atom. As long as it doesn't break apart, okay, so for example, if our phosphate and sodium phosphate in the reactants broke apart and formed something like calcium phosphide and then sodium oxide or something like that in the products, then we wouldn't be able to do that. We'd have to split it up into the two different elements that make it up. But since we see phosphate PO4 on both sides of the equation, that phosphate doesn't break up into separate phosphorus and oxygen atoms, we can treat it just like a single element atom here. So that's what we're going to do, just to make our lives a little bit easier. Okay, it's easier to treat phosphate as if it were just a single element atom. Okay, even though we know it's a polyatomic ion. Now let's take inventory, okay? So what we're going to do is we're going to count up how many atoms of each element we have in the reactants and how many atoms of each element we have in the products. And so we just see Ca in a reactant, so that tells us we have one calcium atom. And then we see Ca3 over here in our products, so that tells us we have 3 calcium atoms in our products. Now let's look at our chlorines. So in our reactants, we have Cl2. So that means we have 2 chlorine atoms in our reactants. And then we just see Cl over here, okay? So that means we have 1 chlorine atom in our products. With sodiums, we have Na3. That means we have 3 sodium atoms in our reactants. And then again, just Na, okay, in the products, so 1 sodium atom in the products. And then we're treating PO4 like it's just a single element atom, okay, just like calcium or chlorine or sodium. And so we just see PO4 all by itself with no parentheses surrounding it in the reactant. So that tells us we just have 1 phosphate, 1 PO4 atom per se in our reactants. But over in our products, we have PO4 surrounded by some parentheses followed by the little subscript number 2. So that tells us we're working with 2 phosphates or 2 PO4s in our products. So that's kind of like having 2 phosphate atoms in our products. All right, so there's our RAP table to begin with. And so we can see here that none of our of the atoms of the elements we have are balanced. Okay, none of our atoms are balanced, so we've got our work cut out for us. So we're just going to pick an element to start with, and we're going to try to start balancing it, right? This equation is definitely not balanced. So let's get started. Right, so we listed calcium first in our RAP table, so we'll try to balance our calcium atoms first. Well, we have to think to ourselves, what can we multiply that 1 calcium atom in our reactants by to make it equal to 3 calcium atoms we have in our products? And you're exactly correct, right? 1 times 3 will equal 3, so we're going to multiply the 1 calcium atoms we have in our reactants by 3, okay, which will equal the 3 calcium atoms we have in our products. We want to have 3 on both sides. And so this 3 that we multiplied our 1 calcium atom in the reactants by becomes our coefficient and from the compound in the reactants that contains calcium. And so that compound is calcium chloride. So we're going to throw a 3 up here in front of calcium chloride. That's going to be our coefficient in front of this compound in our reactants. And so now, okay, we have 3 calciums in our reactants, and then we still have 3 calciums in our products. So we are balanced, at least in terms of our calcium atoms. So let's see if anything else was affected, okay, by multiplying our calcium atoms and our reactants by 3 and adding that coefficient 3 to the equation in front of calcium chloride. And we can check that by drawing a new RAP table. Okay, so we have 3 calcium atoms in our reactants, okay? And then that 3 is also going to multiply over to our chlorine atoms, right? So we're going to end up with 3 calcium atoms in our reactants because of that coefficient 3 in front of calcium chloride, as well as 6 chlorine atoms in our reactants because this coefficient 3 gets multiplied by that 2 that was already next to chlorine, which is going to give us 6 total, right? 3 times 2 is 6. So now we're going to have 6 chlorine atoms in our reactants. Okay, let's look really quickly at the calciums and chlorines we have in our products. Okay, we still have Ca3 in our products. That didn't change. So we have 3 calciums in our products. And then we still just have 1 Cl in our products as well. So that didn't change either, okay? So we've made our chlorine atoms even more imbalanced while balancing calcium. Right now we have 6 chlorines in the reactants instead of 2, with still only 1 in our product. So we'll have to go back and try to fix that later, but at least for now our calcium atoms are balanced. We have 3 calcium atoms on both sides of our equation. Now let's look at our sodiums and our phosphates. We didn't really touch those, so nothing's going to change from our first RAP table, right? We still have 3 sodium atoms in our reactants, 1 sodium atom in our products, and then 1 phosphate atom in our reactants, and then 2 phosphate atoms in our products. Now let's figure out what we want to balance next. Let's just go ahead and try to balance out those chlorine atoms and see what happens with that. Well, we have 6 chlorine atoms in our reactants, 1 in our products. So we have to figure out what we can multiply that 1 chlorine atom in the products by to make it equal 6. Well, you're exactly right? If you're thinking that we can multiply that 1 chlorine atom in the products by 6, and then that will give us 6 chlorine atoms in our products. So that's what we're going to do. We're multiplying that 1 chlorine atom in our products by 6 so that we can balance those chlorine atoms so that we'll have 6 chlorine atoms on both sides. And so that 6 that we multiply our chlorine atoms in the products by becomes our coefficient in front of the compound in the products that contains chlorine. And so that compound in the products that contains chlorine is sodium chloride. So we have to put a 6 in front of the compound sodium chloride in order to reflect this balancing we've done in our chemical equation. So this becomes our coefficient 6. And so that's going to change some things up when we balance our chlorine. So now we have 6 chlorine atoms on both sides, but let's see what else that change, adding that coefficient, affected. And we're going to figure that out by writing a new RAP table. Okay, we still have 3 calciums in the reactants, Ca3, so 3 calciums in the products. We have 3 times 2 chlorine atoms in the reactant, so 6 chlorine atoms in our reactants. And okay, we now have 6 chlorine atoms in our products, right? Remember, this coefficient 6 gets multiplied through by all the atoms that make up the compound that follow it, okay? So we multiply this 6 by sodium and by our chlorine atoms. So now we have 6 chlorine atoms in our products. So we'll write that in our RAP table. We still have 3 sodium atoms in our reactants. But now we have 6 sodium atoms in our products, right? Because we had to put that 6 in front of sodium chloride, and that 6 gets multiplied through to the sodium. So now we have 6 sodiums in our products. And then we haven't touched our phosphates yet, okay? So we still have 1 phosphate atom in the reactants and then 2 in the products. And so now, looking at this new wrap table, we can see that our calciums are balanced, our chlorines are balanced, but our sodiums and our phosphates are still not balanced. So let's just pick one of those and try to balance it. Let's work with our sodiums, okay? That's the next one in line. And so we have 3 sodium atoms in the reactants, 6 sodium atoms in the products. What number can we multiply those 3 sodium atoms in the reactants by to make it equal 6? Yeah, we can multiply 3 by 2, and then that will give us 6 sodium atoms in the reactants to equal the number of sodium atoms we have in our products, right? We want to have 6 sodium atoms on both sides. We can achieve that by multiplying our 3 reactant sodium atoms by 2. And so what we're going to have to do with this 2 is we're going to have to make it a coefficient and put it up in our chemical equation in front of the compound of the reactants that contains the element sodium, okay? And that compound is sodium phosphate, so we put the 2 in front of sodium phosphate, and that becomes our new coefficient. And so you can see that reflected here. This 2 gets multiplied through. And so now we have 2 times 3 sodiums in our reactants, which gives us 6 sodiums total. And so our sodiums are now balanced. Now let's rewrite our wrap table and see if we have to do anything to balance phosphate, or if maybe it's kind of balanced itself out when we balance sodium. So let's draw a new wrap table down below. It's a really wide wrap table, but it'll do. Okay. And so the elements we're working with are still calcium, chlorine, sodium, and phosphate. And so we can see that we have 3 calcium atoms in our reactant still. That hasn't changed. And then we still have Ca3, so we still have 3 calcium atoms in our products. That hasn't changed. Okay, we have 3 times 2 chlorine atoms in our reactants, so 6 chlorines in our reactants. And then 6 times 1 chlorine in our products, so 6 chlorine atoms in our products. And now we have 2 times 3 sodium atoms in our reactants. Okay, remember, this 2 gets multiplied through by the sodiums. It's kind of a weird arrow. And by the phosphates. So we have 2 times 3 sodium atoms in our reactants. So 6 sodiums in the reactants. Okay, and we also have 6 NaCl. So that gives us 6 Na, 6 sodiums in our products. Now let's look at our phosphates. So we haven't touched the phosphates in our products. We still have PO4 parentheses 2. So we still have 2 phosphate atoms in our products. But now we put this 2 in front of sodium phosphate in the reactants. Okay, and we did that when we tried to balance our sodiums. And so what that 2 is going to do is it's going to multiply through this entire compound. And that's going to multiply that 1 phosphate atom we had by 2 to give us now 2 phosphate atoms in our reactants. So in balancing our sodiums, we also balanced our phosphates. Now we have 2 phosphate atoms in our reactants, 2 in our products, and now our entire equation is balanced. Okay, and so it's going to be 3 calcium chloride plus 2 sodium phosphate yields calcium phosphate plus 6 sodium chloride. Okay, we have 3 calcium atoms in the reactants, 3 in the products, 6 chlorine atoms in the reactants, 6 in the products, 6 sodiums in the reactants, 6 in the products, and then 2 phosphate atoms, 2 in the reactants, 2 in the products. Okay, so the same number of phosphate atoms on both sides of the equation, and so we are in fact now balanced. That wasn't so bad, was it? All right, so that includes the supplemental instruction videos. If you still have questions, please reach out via email, and we'll also do some more practice problems during our e-support hours that we have scheduled for this week, which will be held over Google Hangouts.